Okay, so the previous clip ended on this slide, and I was saying that this view here of the task, it's a representation of what you will find on the bench also. It's called a bench aid. And so this teniosolium egg is exactly what you have in the microscopy station for your teniosolium, okay? But you can look onto the bench itself for the printout of the egg, and you can confirm as you look into the microscope that this is indeed a teniosolium egg using the aid, the bench aid. So that's the idea. It's the same for trichuris. I have it also on the bench aid. And you will also see tasks on that bench aid just to help you. And the tasks are basically saying, for example, under tinea, it is saying, observe the characteristic thick radial striations in the shell. So you're looking out for these things that these points that I've stated in the tasks on the bench aid. It to sort of help you quickly confirm and quickly draw, because you have all these tasks that are pointers to say, okay, thick shell, check, striations, check, I'm seeing that, or and so on. That should be helpful, and that's the idea with the bench aid. So I've supplied this for your nematode and cestode, okay? The bench aid, that is, I've supplied it on the bench, and also there is a bench aid also for your trematodes, okay, your schistosome, okay. But you can just quickly take a look at the table that you will be filling in for your nematode. There we go. Again, in the session, just quickly focus on generating a well-observed drawing of whatever it is you have seen and appreciated. Do not focus on this table. You will do that later when you're doing your final report, okay? But for now, for the session, just generate on a nice clear paper the drawing that I will sign against, okay? It's a very time-pressed. It is a very time-pressed lab, so bear with me. This is for the benefit of both ends. On your end, you won't have as many labs when you get back. And then on my end, the marking can be done quicker. Okay, so that's the table 2. And then the other table, the table 3 for the cestode, is the same thing. Please focus on your drawing, but everything applies. You know, the same instructions I said earlier. Appropriate table, label drawings when you finally get to put in your drawing into this table. Okay, everything applies. Please, please, that's where your marks are. Parasitology is all about your observed drawings, especially on the microscopy. Okay, so here we are. The trematode, the bench aid that you will find looks like this. Okay, and then of course the stations are supplied, the actual microscopy of these images seen here. Okay, and you have a task on the bench aid just helping you, guiding you through to point you in the right direction when you're trying to make the observations. Okay, so please read the task. For example, the first task on the bench aid is saying observe the size of the ova. So you comment on the known size. Okay, so this is literature. You go to your literature. And of course, you don't have to do this in the session. This is for later. Okay, but you need to remember the tasks here. Okay, even for the other ovas, you're expected to comment on the known size of the egg. Okay, that's also important. This is from literature, not really measuring it. Okay. Okay, so that's the table you will fill in for the trematodes, your schistosome manzoni and your schistosome hematobium. And that is the last part for our microscopy, our part A. Okay, so we can quickly conclude with the part B, the immunodiagnostic tests. So in our slide there, you can see I mentioned the enzyme, the other types of immunodiagnostic tests, the enzyme immunoassays, the agglutination tests. This one you will find especially with Trypanosoma brucei or gambiense, where we use it for screening purposes in large populations. Okay, so that's another commonly used immunodiagnostic test. But the one that is even more commonly used is the immunochromatographic assays. It's a mouthful, but these are commonly used, the rapid tests, okay? Immunochromatographic assays. Okay, so that's why we will just quickly run through the principle to help us just get the overall scope of immunodiagnostic tests. So we'll run through the principle of rapid tests, rapid diagnostic tests, to get the scope overall of immunological methods. Okay. So there's a note here, basically with whatever immunologic test that it is, you're trying to detect the parasitic antigen, okay, molecule, or you're trying to detect the antibody generated from the host, okay. So to appreciate this, we have on the bench a cassette format, exactly as seen in this diagram here. So the one we are appreciating is a Plasmodium falciparum rapid rapid diagnostic test cassette. Okay, the format here is a cassette format, and you have the parts: a buffer well, a blood well, the results window. Okay, so the principle of the Plasmodium falciparum RDT is we are detecting antigen, in this case antigen, which happens to be the molecule histidine-rich protein 2. Okay, and so the principle would be, or is rather, we supply drops of blood into the blood well, and then we put in a few drops of the buffer, because remember we need a solution for movement into the results window. So we supply some drops into the blood well, and then it will pick up the blood, of course, and then continue the movement transversing inside into this nitrocellulose membrane, the results window. That is the nitrocellulose membrane, which has a C line, a control line, and a T line. So on the T line, there is a fixed antibody, which therefore now is designed to bind, if the sample is histidine-rich protein positive, malaria positive, it will bind to that histidine-rich protein 2, because it's the antibody, it's fixed on the test line. It will bind all the available molecules in the positive sample, and that binding will generate a color. That is the design of these immunochromatographic tests. There will be a color being generated because of a color complex. Okay, and so once we start to see that T line, we start to already have a picture of the result. But we cannot conclude that it is a positive result until the movement is completed and there's a visual indication there on the C line. Okay, so control line is a validity line. Yes, I'm sure you remember our experimental models. So the control line will now confirm that it is a valid result, and we can read it as a positive result. Okay, so that is the design of these cassettes. The movement has to transverse the entire nitrocellulose membrane, okay, where the results window is. Okay, so we have that confirmed um, result or valid result when we have that C line, control line. So this is only one example of how rapid tests are designed. So you can have, for example, under Leishmania, which is designed to detect antibody, right? Okay, so meaning on the T line, for example, it is fixed with the antigen, and then now the blood with the Leishmania infection, when it comes all the way into the nitrocellulose membrane, it is going to bind to the antigen because of the antibody present in the blood. So you see the interplay between antigen detection and antibody detection. So that is the principle that is most important with these diagnostic tests, that interplay between the molecules. Okay, so that's just our one example, and I hope it made some increase your understanding of some of these tests that you read about. Okay, so in conclusion, for your part B, your task 3, part B, is to draw the provided RDT cassette. So all the parts that you see, draw it, and then also answer the questions supplied in the leaflet. Okay, that is it. Okay. This part, task 3, you don't have to complete it in the lab because it's simply a picture that you can take, RDT picture, and finish up later. Okay, so this is the task that I'm not signing on. Task 3, I don't need to sign it. Okay, but I can sign off here. Thank you so much for your patience. Thank you so much for your acceptance of this amateur videography. Okay, thank you.